You know, sometimes I just don't give up easily. Just trying to see if we could have this class. Okay, so I've just created another class right away to see. Please, if you connect, you can indicate by typing if network. King Allison, hi, you're welcome. If network is manageable, please, if network is now a bit manageable, let me know. We were having this class before, you can see this, but unfortunately network messed us up. You know, Niger, we've got no choice. We have to continue to manage with whatever situation we find ourselves. So Angel, you're welcome. James, welcome again for connecting. So I don't know, I think because from this device, it seems to be, the network seems to be stable and okay now. All right. And since it's okay, it means the camera is on, going. So we want to kick off. Let's see if we can do some more things. Let's see if we can do some more things. For those that are just connecting to the class, we had already answered from question 1 to 8. I really don't know the question number it stopped at. So can someone tell me from there? Okay, can someone tell me from there which question number? Which question number? Who am I going to ask? James Idowu. Did you guys say the explanation of question number 8? Can you indicate, please? This is hanging again. This is hanging again. Please, which question number did you see this question number 8 solved? Were you able to say that? Okay, no. What about question 7? James, what about question 7 where we add something about maximum power transfer? This, did you get the explanation or the network disturbed at this point? For question 7. For question 7, please indicate so that I can kick off right away. Question 7, I mean number 6. Okay, that number 6, the question we stated was wrong. The question was wrong, and that's why we didn't proceed. So maybe let me deal with this question number 7. That question number 7, I've written something here. The correct option is C, and I wrote this. Let me read out the question, please. You guys should follow through as I read out question 7. Is the network disturbing now? James, you just posted something. Is the network disturbing now? Or you are referring to the previous one? Is the network disturbing now? All right. No, sir. Okay, listen, thank you for indicating. Question number 7, the question reads, a cell of internal resistance, small letter r, a cell of internal resistance, small letter r, is connected to an external resistor, capital letter R, is connected to an external resistor, capital letter R. The condition for maximum power transfer is, the condition for maximum power transfer is, then option A, we have capital R less than small r, that is external resistance less than internal resistance. The capital R is external resistance. The small letter r is internal resistance. So I'm going to use that to read. Option B, capital R equal to 2 times small r. That is to say that external resistance equals twice internal resistance. Then option C, external resistance capital R equals internal resistance small r, which happens to be the correct option. Then option D, capital R is greater than small r. So the correct option I said is option C. For a cell to deliver maximum power to the external circuit, the internal resistance, small letter r, is expected to be equal to the external resistance, capital letter R. That's the condition. And I took my time to I explained something briefly, that this particular question is just a little bit, let me say, above. I don't know if I should use that word, but that's the truth, because even during my time, I didn't do this at O level. I didn't do that at O level, right? I actually studied this in a course during my 100 level years, okay? That course is titled Circuit Theorem. On this channel, you have a playlist dedicated to that course, Circuit Theorem. It's coded FEG 103. When I studied that in Unizik, Nnamdi Azikiwe University, Awka. So that is where we discuss stuff about network theorem. We have something like Thevenin's theorem, Norton's theorem, superposition theorem, maximum power transfer. We have the delta star delta transformation. Anyway, don't worry about, nobody's going to stress you much about that. Not even sure of much. Nobody will stress you about those ones. Just take note of this. We've seen the question, and I've told you something like that exists in electricity. Quite sad that it's a bit beyond the level we are dealing with right away. Okay, so having explained that, we are moving on to the next one. That is what we have in this question number 7. Then question number 8. Question number 8. This was a question that I solved here. It reads, a current of 100 milliampere. A current of 100 milliampere MA passes through a conductor for 2 minutes. Passes through a conductor for 2 minutes. The quantity of electricity transported is, then we have the options A, 200 coulomb, option B, 50 coulomb, option C, 12 coulomb, option D, 0.02 coulomb. And I went ahead to explain that in the question we're given the current. We're given the time during which the current was transported. The current is 100 milliampere. You have to convert from this milliampere. Milliampere is a metric prefix unit. It is not the SI unit of current. Milli means divide something by 1,000. Divide something by 1,000. And you know that 1,000 is the same as 10 to the power of 3. So milli means divide that value by 1,000, or you can see it as multiply that value by 10 raised to power minus 3. 10 raised to power minus 3 is the same as divide by 1,000 or divide by 10 to the power of 3. Is that okay? All right. This stuff is still hanging and hanging and hanging. I don't know. So that is why for this question, I had to divide this 100 by 1,000 in order to convert it to the SI unit. Dividing this guy by 1,100 give us 0.1. If you divide 100 by 1,000, you get 0.1 ampere. That removes the milli. Then the time was given to us to be 2 minutes. Convert the minutes to second by multiplying these two by 60. If you multiply 2 minutes by 60, you get 120 seconds. Now we are asked to calculate the quantity of charge transported, right? Now, we have this formula that quantity of electricity is current times time, as simple as that. So multiply 0.1 by 120, you get 12 coulomb. So that is it. And the option, as we have here, is option C, which is what I selected and wrote on the board. All right, I hope you are following through as we, okay, that's good. So let us move on to question number 9. Let's move on to question number 9. And see what we have there. Please, we'll manage the network as it is today. Okay. Question number 9 reads, a cell of internal resistance, 0.01 ohms can be measured accurately using a cell of internal resistance 0.01 ohms can be measured accurately using so we have devices provided. Option A, ohm meter. Option B, potentiometer. Option C, we have electroscope. Option D, we have meter bridge. So which of these instruments can be used to measure, a cell that has that internal resistance 0.01 ohms? I hope this has not cut. Okay. Now continue to manage, like I said, the situation. This is a bit sad, but we'll keep moving. A cell of internal resistance 0.01 ohms can be measured accurately using which of the following instruments? 1, we have ohm meter. That's option A. B, we have potentiometer. C, we have electroscope. And D, we have meter bridge. So which of that, the instrument provided, do you use to measure, a cell that has that? We use potentiometer. In our last class, I showed you potentiometer. I think I showed you something like that. This is your potentiometer. Some of you may have seen it before. This guy uses it to measure the EMF of a cell. This instrument. Okay? It has a wire, a 1 meter wire. Now this particular one is Constantine wire tied. So you have the negative and the positive end. So this instrument, potentiometer, generally is used to measure the electromotive force of a cell, of a battery. Can use it. So of course that's the answer. You use potentiometer. And the option that has that is option B. Option B, potentiometer. Good, Angel, you had answered the question. That's good. Peter Lawrence, good. Bram Sprott, you're welcome to the class. Okay, guys, we are moving on to the next question, having answered this. So questions on current electricity, they are not usually so tough anyway, but I've got others I'm going to add up. Let's speed up a bit. Question number 10. The unit of quantity of electricity is called, unit of quantity of electricity is coulomb. You've seen it before. See. Okay, coulomb. In your exam, there are some questions as you are reading them. Yeah, you don't need to really even look at the options before you come up with what the answer should be. Such that you know those things so well that you're not going to the option just to go and check for your answer. Except otherwise, if you don't see that answer, then you can now check if there is another unit that have been used, which that thing could be equal to. For example, look at this guy. This coulomb. Instead of seeing coulomb, I've not checked the option anyway, but we are asked the unit of quantity of electricity is what? I used to know it to be coulomb. But suppose maybe in the option there is no coulomb. This guy can still be quoted as amps per second. That is ampere second, not per second. I'm sorry about that. Ampere second. This coulomb you are seeing is the same as ampere second. Why? Because current is in ampere and time is in second. So current times time will give you ampere times second. Anyway, let's look at the options provided. Option A, the ampere. Option B, the volt. Option C, the coulomb, which is the correct answer. And then option D, the ammeter. So here, the correct option is C. Coulomb. Like I said, coulomb or ampere second. Ampere second. That coulomb is C, or ampere second can be written as A and then S this way. All right, we are done with that. Question number 11. Question number 11. Follow along as I read that question. Question 11. This is question 10. So question number 11 reads, a parallel arrangement, take note of this, is a calculation question. A parallel arrangement of 30 ohms and 6 ohms resistor. Once again, let me take a look that the network has not messed up. Okay, good. We've got as good as, more students connecting. Thanks to God for that. A parallel arrangement of 30 ohms and 6 ohms resistor is placed in series with an 8 ohms resistor. You get that? A parallel arrangement of 30 ohms and 6 ohms resistors is placed in series with an 8 ohms resistor. If the potential difference is 30 volts, if the potential difference is 30 volts, if the potential difference of 30 volts rather, if a potential difference of 30 volts, if a potential difference of 30 volts is connected across the whole circuit, the current in the 3 ohms, group 1, the current in the 3 ohms resistor is, I don't know, you didn't mention 3 ohms resistor. You mentioned 30 ohms from what I'm seeing here, and then 6 ohms. This thing now, if I decide to solve using the 30 ohms, I don't know if the option will be there. If I decide to solve using the 3 ohms, I don't know if the option will be there. I've warned you guys before now. Make sure you are consistent. I don't understand some of you. The laziness, yes, I must say, it's the laziness in some of you students. Only God knows. I told you guys, come up with questions. Anyway, I know what I'm going to do. I think from this week, I'm not going to allow you guys to search for questions again. I will just come online and then maybe I'll start dictating questions. We'll be dealing with, at least I have my sources of questions and stuff like that. I understand you guys have been trying. It's not easy. But you see, whenever you are submitting something to someone or to a public space, in as much as we are humans, you want to make sure, try as much as you can, at least risky mistakes. Don't make it. Don't make it. Now you have to provide questions, and it's not only one person providing it. In each group created, there are about 10 groups. Each group has more than 10 people, 10 students. If you're the one that supplied this question, you have to read through. Make sure that the question is consistent. What do I mean? The numbers you are using, they agree with what you have there. You used 30, you came and changed it to 3. I'm just confused now. And I told you guys something. I try to be real once I come online, right? Live. It's so that any question we can't solve, if maybe the question I can't interpret it, I have to be honest. Because in exam hall, there are certain questions you're going to meet, you might be shaking a bit. It might shock you a bit. You don't waste time there. I've done something like that before. This question is disturbing you, leave it, you move on. Because that's the spirit of examination. You are not the one that sets the question. And so I don't usually have that time to say, go through all these things before I come live the way it is. So please, you guys should take note of this. Make sure you are consistent with the numbers you use whenever you are supplying questions. If I assume that, we are calculating the current in the 3 ohms resistor as the question presented, that 3 ohms resistor is not in that question there. I'll read the question and then I'll use possibly my experience to see if I could correct something here. A parallel arrangement of 30 ohms and 6 ohms. From what I'm seeing here, the only correction that will be made is from that 30 ohms. Maybe that 30 ohms was actually 3 ohms, which was why towards the main question, we were asked to calculate the current in the 3 ohms resistor. So follow through. Let me read the question now, assuming it to be 3. A parallel arrangement of 3 ohms and 6 ohms resistors is placed in series with an 8 ohms resistor. If a potential difference of 30 volts, is connected across the whole circuit, the current in the 3 ohms resistor is, so we are going to solve with the 3 ohms. One similar kind of question I solved in our previous class, yeah, under capacitor, I just decided to touch one, two questions on electricity. I told you that it's not necessary to always draw the diagram per se, not absolutely necessary, but for further emphasis and clarity, sometimes I am the teacher. Yeah, I'm the teacher, so I feel like present the diagram. So let us see now. We have two resistors. Initially, they were connected in parallel. That's according to the question. So I'm going to have something like this. For parallel connection, both resistors will meet. You know, each end of both resistors will meet at one point. So this is parallel connection. So you notice that this resistor at this point and this one, the terminal, they met here. Then this, the terminal here and the terminal here, they met here. So this guy is parallel arrangement. And they say that this whole stuff is connected in series. It's placed in series with an 8 ohms resistance, or resistor rather. So connected to this is 8 ohms. So let's say this is the 3 ohms, and then this is 6 ohms. Connected in series with this guy. Now the whole circuit had a potential difference of what volts? 30 volts. So this is what the diagram is going to look like. We are now asked to calculate the current flowing through the 3 ohms resistor. Through the 3 ohms resistor. Now pay attention as I read out the options. Option A, 15 ampere. Option B, 10 ampere. Option C, 3 ampere. Option D, 2 ampere. Please, I want to say this clearly in case we solve this question and it happens that we did not get any of the options here. I won't resolve this. I won't resolve it, assuming this to be 30. I wouldn't. The number doesn't matter. Let's take it for this question that the number doesn't matter. Yeah. This is the interpretation of what that question is. And so whatever the number is no longer a problem. So I'm going to solve this based on what you're meant to do if you have this question. So I'm wiping this part. Then let us see what we've got there. Solution to this, we'll solve and then go for the option. So what you have to do first is to get the total current in this circuit. That's the first thing you have to do. Get what I said, total current in this circuit. If you get the total current in this circuit, then from that total current, you can now find out the value that flowed through this 3 ohms resistance. Now, the current comes out this way from the positive terminal. It's moving like this. How do we get the total current in this circuit? We'll get the total resistance. If I calculate the total resistance, I will now apply Ohm's law. So how do I get my total resistance? I'm going to be fast. These two guys are in parallel. And I'm going to show you a quick formula you can use to calculate the combined resistance anytime 2 resistors. Please, this formula is used specifically for 2 resistors. Take note of that. Anytime 2 resistors are connected in parallel, the fastest thing to do to get the effective resistance of those guys is to apply this formula. Multiply both of them and then divide by their addition. I repeat, multiply both of them and divide by their addition. Okay, I have R1 and it is in parallel with R2. If I try to get the combined, the total resistance of these two guys, since they're in parallel, it's going to be R1 times R2 divided by R1 plus R2. So fix this guy in your brain. Are you getting me right? You use that for, instead of punishing yourself, being 1 over R equal to 1 over R1. Yes, we know that you know this song. 1 over R this, 1 over that and that. We know. But could you just stop wasting much of your time in exam hall in something of this kind when 2 resistors are in parallel? To get the combined resistance, please apply this formula. Therefore, I'm going to say that the combined resistance is equal to, for these two guys, is going to be 3. So let me write out the formula in a way to guide you. Let me take this as R1, take this as R2, and permit me to take this as R3. So it's going to be R1 times R2 divided by R1 plus R2. You know, once you resolve this guy in parallel, and you get one resistor value for it, for these two guys in parallel. You get the combined resistance for two of them. That combined resistance, which is now a single resistor, will now be connected in series. You know, just like condensing, combining this whole thing to get only a single resistor. That single resistor will now be connected to these 8 ohms in series. So this whole thing you are seeing, which is the parallel total resistance for these two, will now be in series with this guy. And because it is in series with this third resistance, you simply add R3. Simply add the third resistance. So this is the effective, the combined resistance for this circuit. This will now give us, let's fix up the values, 3 times, this is R2, and this is R3, this is R1. 3 times 6 divided by 3 plus 6, and then plus R3. R3 is 8. Please don't look at this formula as something to, as if, really? So we have something like this, calm down. If you apply your knowledge of mathematics, work out the LCM of this. Are you getting me, right? Then if you want to cross multiply, you cross multiply and then make R subject to the formula. It's going to give you this. So it is not as if it is one big mathematics there, okay? So with this, we now have our R to be equal to 3 times 6 is 18. 3 plus 6 is 9. 18 over 9. 18 divided by 9 is 2. 2 plus 8 will give you 10 ohms. So the total resistance in this circuit is 10 ohms. Having calculated the total resistance for this circuit, I will now use it to calculate the total current. Total current using Ohm's law is equal to voltage divided by resistance. Total current using Ohm's law is equal to voltage divided by what? Resistance. I'm wiping this. The video lesson on this topic, like I said, in our playlist, Physics 101 and Physics 102 playlist in this channel, I treated all of these stuffs. So, applying Ohm's law, our voltage, the potential difference is 30, and then we are dividing it by what? The total resistance, which is 10. So, the total current produced by this cell in this circuit is equal to 3 ampere. Is equal to 3 what? Ampere. Now, this 3 ampere flew out, it flew out of this cell, and then moving around the circuit. At this point, is going to share into 2. When the current gets to this point, it will share into 2. One will move on through this 3 ohms resistor. Let's call it I1. Let's call it I1. Then the other will flow through this 6 ohms resistor resistance. Let's call it I2. The current that will flow through these 8 ohms will be I1 plus I2, because if these two currents are splitting at this point, this is a principal node, a main junction, a principal junction. If the current splits here, one will go through these 3 ohms, the other will go through these 6 ohms, and both of them will move to this terminal, combine again before they move into this 8 ohms resistance. So if you were asked to calculate the current flowing through this 8 ohm resistance, it's simply going to be the total current, which is 3 ampere. Now, but that is not what we are asked. We are calculating the current flowing through these 3 ohms. Like I said, if the current gets here, it will share between these two guys. Now, there's a formula you can use to get that. I'm sorry, but do I owe you an apology in that? I don't know. It's just that I like people a lot, and I love, good relationship. But hey, I'm going to withdraw my sorry. I'm going to withdraw it. You know why? Because the principle you should use to quickly solve this in the exam is, again, something a bit advanced into 100 level. Like I said in that circuit theorem, or a little in advanced physics, there is this law under electricity we call Kirchhoff's law. From there, we apply certain knowledge to determine certain current flowing through, a circuit. In fact, we refer to the principle as current divider rule. A parallel circuit divides current. So I'm going to show you that formula where you use resistors. You use resistor value to get the value of current in any circuit element, any resistance circuit element. Once again, on this channel, circuit theorem playlist, that is FEG 103. You have that current divider rule there. You have it there. And I think also in Physics 101/Physics 102, I still dropped that current divider rule. So in this case, if I want to get I that flow through these 3 ohms resistance, I3, But we labeled it as I1, so let me use that same, the current flowing through here. It is going to be, current is inversely proportional to resistance. Current is inversely proportional to what? Resistance. So this is going to be this resistor here, which is R2, all over, since current is inversely proportional to resistance, and I'm calculating the current through this 3 ohms resistance, this R1, I get me right. That R1 will come to the denominator. So it's going to be R1 plus, you now add R2. Then multiply it by the total current you calculated. Once again, you are calculating I1. I1 is going to be equal to, since the current is sharing between these 3 ohms and 6 ohms, then that current flowing through this guy is going to be equal to this resistance, the other opposite resistance, the one that it is sharing that current with, all over the addition of both of them, then multiply by total current. I am pretty sure 100% both wire and jam, they can't go further than this type of simple circuit. Yeah, they can't. If you move on to advanced level, we'll have other complex circuit. I think highest they can go for trying to bring something of that kind to you guys, they will limit it to a simple circuit as this, so that you don't need to overstress yourself in how to get the formula. You can see this. Now, if you want to get I2, for example, and you still want to use this kind of formula, what will you do? You want to get I2. To get I2, which is the current flowing through this 6 ohms resistance, is going to be equal to the opposite resistance, the resistor sharing the current with it, which is going to be R1 now. If I'm calculating I2, it's going to be equal to R1 all over R2 plus R1 or R1 plus R2. Then whatever you get, multiply by the total current you calculated. So I1 will now be equal to R2. What's the value of R2 here? 6 ohms all over 3 plus 6, because R1 is 3, and then plus 6, multiplied by total current, which is 3. And then I1 will now be equal to 6 times 3 is going to give you 18. Then 3 plus 6 is 9. 18 divided by 9 will give you 2. So 2 ampere current will flow through this 3 ohms resistance. The current flowing through the 3 ohms resistance is 2 ampere. 2 ampere. And that's the answer to the question that we're being asked to find, right? If I know that 2 ampere is flowing through this guy now, let me ask you, which current is flowing through these 6 ohms? Which current is flowing through these 6 ohms? Definitely it's going to be 3 minus 2, which is 1 ampere current to be flowing through this. 1 ampere current. Then the one flowing through these 8 ohms is the total, because like I explained, the total, which is 3 amps. Like I explained, these 2 current that, that's shared here, right? Or that were obtained from this single total current. When they move through these 2 resistors, coming here, they will combine to form 1 total current again, which is 3 ampere. And then it will pass through this 8 ohms resistance. So that's how you handle this question. You say, see the steps. Get the total resistance. Use Ohm's law to get the total current. Apply current divider rule. Permit me to write this formula is CDR. Using CDR, at least so that you get to know the name. That CDR is an abbreviation for current divider rule. By the time you are done with your exams and other things, you want to learn more about this, GMAT 41 is right here as you prepare for your advanced level. Take note. I am right here. So come back. Come back. Let me help you. Using CDR, current divider rule. We have this one we call VDR, voltage divider rule. Because series circuits divides voltage, while parallel circuit divides current. You want to remember this. Then here, using Ohm's law. Using Ohm's law. And this is the reason why you want to make sure you take the video lessons on this channel in our playlist. Okay, take them, because there it will guide you to understand all these principles as much as possible. So if I come online and start dealing with them, you can follow through. That's good. Praising 2 ampere correct. Angel 2 ampere correct. Andrew 2 ampere correct. So we are done with this. And if you look at the options given to us from the question, option A, that's question number 11. Option A, 15 ampere. Option B, 10 ampere. Option C, 3 ampere. Option D, 2 ampere. So the correct option is D, 2 ampere. All right, we are done with this question. Finish up. Can screenshot like I used to advise sometimes to be fast. So we move on to the next question. I hope network is not disturbing again from your end. I hope you are managing up with the network. All right, let's move on. So I think I've given you enough time to look at this. At least I helped you out to draw the circuit so you get to understand what is happening there. I'm wiping this as we take question number 12. All right, question number 12. It's not a calculation question. It said, what is the unit of electric current? Type the answer there. Question 12. Unit of electric current. Do you need to be told? Is it not ampere? So let's move on. That's option C from here. No time. Okay. Ampere. Option A is volt. Option B is ohms. Option C is ampere. Option D is what? Anyway, let's try to remind ourselves of the quantity that has the unit given by A, B, and D. Option A is volt. Volt is the unit of voltage or potential difference. Option B is ohms. Ohms is the unit of resistance. Option C is ampere. Ampere is the unit of current, which is the correct answer here. Then option D is watt. Watt is the unit of power, electrical power. All right, question number 13. Question number 13. It is still not calculation. And that question 13 reads, in a simple circuit, if the voltage increases, while the resistance remains constant, voltage increases and the resistance remains what? Constant. What happens to the current? What happens to the current? I hope you understand the question. In a simple circuit, if voltage is increased while the resistance remains constant, what will be the effect on current? Truly using Ohm's law, the current will also increase because the current will behave in the same way as the voltage. Remember the law. Current is directly proportional to voltage, or voltage is directly proportional to current. Question number 13. Option A, it decreases. Option B, it does not change. Option C, it increases. Option D, it becomes 0. Option C is the correct answer. It increases. Option C. Current increases. Current increases. Now, I would not just want to leave the answer at this. I'll give you a little reason. One, from the formula proposed by Ohms, according to his law. Then secondly, from the graph of Ohm's law. These two guys, you can use it as a means or a guideline to explaining why the current will increase if the voltage increases and the resistance is kept constant. Now watch. From Ohm's law, we know that V is equal to IR. So if this guy does not change, resistance remains the same. It does not change. Let us assume that we say that resistance should be 2 ohms, for example. Resistance should be what? 2 ohms. If voltage is 10 volts, for example, voltage is 10 volts, calculate current and see. Current is going to be 10 divided by 2, which is 5 ampere. Remember, the resistance is not being changed. So look at another one. We are increasing what? The voltage. So keeping resistance constant. Let's see the effect on current. If the voltage, say the voltage increased now to 20 volts, resistance remains the same, 2 ohms. What will be the current in this case? Current is going to be voltage divided by resistance, which is going to be 10 ampere. Did you notice that as voltage increased from 10 to 20, the current increased from 5 to what? 10. This happens if the resistance remains constant. So I've interpreted this. Another thing is from the graphical representation of Ohm's law. If you plot voltage against current, you're going to get this graph, a straight line graph that passes through the origin. Now the slope of this graph is your resistance. Slope is equal to resistance. If you plot voltage against current, the slope remains the slope is the resistance of the material. Now, in this case of a straight line, slope remains the same. If you have a straight line like this, the slope at any point, like here, I took the slope at this point and at this point. If I decide to take the slope here, the slope will still be equal to the resistance. Slope still equal to resistance. If I said no, I want to take the slope here, the slope at this point will still remain the value of the resistance. And let me tell you, since this is a straight line graph, the value of slope you get here, if maybe you took the slope like this, will be the same as the value of slope you get here. If you took it with this small value, it's also the same as the slope you get here, because this is a straight line graph, which means that resistance remains constant. It does not change. Now this graph you are seeing, as voltage is increasing, resistance is also increasing. That is the interpretation of this graph, and you can prove it by looking at these trace. Let's assume that you have voltage here, trace dot 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 dot. The current will be here. If voltage increases, let's say here, dot, 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 it touches this graph, bring it down. You notice that the current still increases. From here, you are reading from 0. This is going up, increasing. This going right, increasing. If the voltage increases to this point, dot, 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 you notice you follow it down. Once it touches this graph, follow it down, you observe that the current also increased, went further. So that is it, this type of questions, right? To tell you the truth, all these non-calculation questions, sometimes they are the ones that are difficult to answer sometimes. Because where you would have to bring your analysis from to be able to interpret that question might just be something that your brain may not be able to crack quickly. In exam is possible. That is why if I answer a particular question, sometimes I try to make the analysis. So from this formula, Ohm's law formula, and the graph, and even Ohm's law statement, although this guy is already Ohm's law statement, it tells us that if you keep resistance constant, resistance does not change. If you increase the voltage, the current will also increase. All right, guys, we are done with that particular question, and this takes us to question number 14. I hope the network is still intact. Good, Angel, that's wonderful. Andrew Chiagozi, that is wonderful. Current will increase. Pressing, current will increase. That's good. So you guys are on point. You're on point. Now let us move on to our next question. Number 14. Ohm's law states that, this anyway, it's understandable. Most times their questions are just a kind of this way. If you come to current electricity, nothing is there in this topic. That's the truth. Question number 14, Ohm's law states that option A, V equal to IR, and that of course is the answer. Option B, P equal to IV. P equal to IV is not Ohm's law. P equal to IV is one formula of electrical power. Option C, Q equal to IT, you've seen it a lot today, that is not Ohm's law. Option D, E equal to MC squared. That formula is Einstein's equation of special relativity. Einstein's energy equation of special relativity, that's E equal to MC squared. Of course, that is not Ohm's law. The correct option is option A, which is V equal to IR. That's Ohm's law. You see it here already. Let's move on to the next question. Question number 16. Question 16. Right? I mean question 15 rather. Question 15, still non-calculation. Which of the following materials is a good conductor of electricity? Which of the following materials is a good conductor of electricity? Option A, rubber. Rubber is not a conductor. Rubber is an insulator, so it's not a conductor of electricity. Okay. Option B, wood. Wood is an insulator. It is not a conductor of electricity. Option D, copper. Good. Copper is a good conductor of electricity. As a matter of fact, I think after silver, aluminium, the next good electrical conductivity metal should be copper. Yeah. Silver is number 1. I think followed by copper and then aluminium. Yeah. Silver number 1, copper, then aluminium follows. So copper is the correct answer here. Option D is glass. Glass is not a conductor of electricity. So the correct option is C, copper. This takes us to question number 16. I'll finish up with what is on the board. Be fast. You can screenshot if you want to screenshot. I'll be wiping this part of the board. I'll be wiping this part. Okay. I'm trying to be a bit fast, a little. I don't usually go so fast whenever I'm teaching you guys. Because it's not all about coming to answer questions here. And that is why let me advise you guys against this, please. Say that you're preparing for exam and then you just pick only one question from a topic and other things. And then some persons will tell you, these are jam questions, repeated question and other thing. Who told you that that question will be repeated? Who told you that? I always tell students, that is why you want to start preparing as early as you can for any professional exam. So you can be able to touch all nooks and crannies of topics. Because in my entire exam, there are some of you that already have a ready-made answer ahead of this exam you are going for. And I'm wondering where you got these answers from. Imagine you enter the exam hall and then on clicking, you notice that anyway, I know I'm saying this. A lot of people are out there now. Say this jam question, jam most repeated. Anyway, it's okay. I follow trick and learn 1 or 2 things, but please have an open mind. Prepare very well. That's why GMAETS, if I come online, I pick a topic and then we deal with it. Things you are meant to know as much as possible there. And that is good for your health. It's good for you, what we are doing here. Question number 16. If 2 resistors, R1 and R2, are connected in series, the total resistance, R total, is given by, 1+1 question. Total resistance when resistors are connected in series is R1 plus R2. We are told R1 and R2. So if they are connected in series, the total resistance, R total, is given by, you add them. Option A, R total equal to R1 plus R2. And of course, that's the correct answer. Option B, R total equal to R1 times R2. That's not the answer. Option C, R total equal to R1 minus R2. That is not the answer. Option D, R total equal to R1 plus R1 over R2. So the correct option is option A. Okay, option A. We move on to question number 17. We have 20 questions here supplied by group 1 of the GMAETS 41's JAMB and WAEC class. Right? We have several groups amongst the students, up to like 10 groups. The questions on the electrostatics and capacitor in our last physics class was supplied by group 10, and then we'll move on to group 1. But as if I'm going to be taking this work now, seeing that the exam is fast approaching, rather than allow you guys to do that. But all the same, in either ways, I will see what we can do. Question number 17. In a parallel circuit, the total current, I total, in a parallel circuit, the total current, I total, is equal to, in a parallel circuit, the total current is equal to, option A, I total equal to I1 plus I2 plus I3. In a parallel circuit, the total current, I total, is equal to what? I total equal to I1 plus I2 plus I3. That is option A. Option B, I total equal to I1 times I2 times I3. Option B is not the answer at all. Option C, I total is equal to I1 minus I2 minus I3. That is not the answer. Option D, I total is equal to I1 divided by I2 divided by I3. That's not the answer. The correct option is option A. In a parallel circuit, remember I told you a parallel circuit divides current. Parallel resistance circuit divides current. You saw it when I wiped it, at the principal junction, the total current divided into two, which I labeled I1, I2. So in a parallel circuit, the total current, how do you get it? You get the total current simply by adding the split current. So the correct option is option A. Option A, I total is equal to I1 plus I2 plus I3. In fact, the video lesson that covers current electricity, when I derived resistors connected in series and resistors connected in parallel, for those connected in parallel, this was our start up for the derivation. So you want to take note of this. Parallel circuit, they divide current. Therefore, to get the total current, you add the individual current. But in series circuit, you want to take note of this. Series circuit does not divide current. So the total current is what we flow through in series circuit. Are you following, right? What a series circuit, a series resistance circuit does is to divide voltage. Which means an examiner could have asked this question. In a series circuit, the total voltage is... If the circuit is series and series circuit divides voltage, then the total voltage will be equal to V1 plus V2 plus V3 plus in that order. Again, you see it in the video lesson on this topic. All right. Before I move on to question 19, right? Question 18. Let me say this with respect to capacitor. We saw it in our last class. If it is capacitor, remember capacitor circuit can also be in series or in what? In parallel. For capacitor, parallel circuit divides charge, Q. Parallel circuit divides charge, Q. Do you get that, right? Because in capacitor, what replaces current there is charge. When you talk about resistance, you refer to current. You talk about capacitor, you refer to charge. Both of them, whether resistance circuit or capacitor circuit, both of them have voltage. So I want to take note of that. And in both of them, series arrangement divides voltage. Then parallel arrangement is in resistor connection. Parallel arrangement divides current. Then in capacitor connection, parallel arrangement divides charge. If it is in terms of voltage, voltage in parallel arrangement are the same. If I have a parallel connection, the voltage across any of the elements will be equal, will be the same. But in series, voltage will be different. So take note of all these concepts. Let us move on to question number 18. What device is used to measure electric current? We've talked about this before, ammeter. Question 18. The correct option is, I think ammeter is option B here. So option B, ammeter. And I hope this has not cut off from your view, like the space I'm covering there. Okay, it's still showing. Good. We're moving on. Question number 19. Question 19. Angel, thank you for following up with your answers. That's great. Okay. Question 18. What happens to the total resistance in a circuit when more resistors are added in parallel? What happens to the total resistance in a circuit when more resistors are added in parallel? This is what you should know about parallel arrangement. If resistors are arranged in parallel, the overall resistance, the effective, the combined, the total resistance, the resultant resistance must be less than even the smallest resistance in that circuit. So in this question where we are asked, what happens to the total resistance in the circuit when more resistors are added in parallel? We will expect that the total resistance will decrease. Option A, it increases. Wrong. It will increase if the resistors were added in series. Because for series, you add this plus this plus this plus this. All right, for series resistors. So Option A is saying that the resistors will increase is not the correct option. Option B, the total resistance here as given from the question, it decreases, and that is the correct answer. Option C, it remains constant. No. Option D, it becomes zero. No. I want you to take note of this. See, imagine I give you this circuit. Let's assume I have this. Say that this is, resistors can also be drawn with something like this. I used the rectangular format earlier. I'm trying to now use this zigzag format. This guy you are seeing is in parallel, because if current enters here, at this point the current will share into three, as you're seeing. These are resistance R1, R2. Let me assume that this resistor is 2 ohms. Let's add this 5 ohms. Let's add this 6 ohms. Right? The current will share into three, I1, I2, and then I3. The total resistance you have in this circuit, right? The total resistance in this circuit will be less than 2 ohms. The total resistance in this circuit you are seeing will be what I said, less than 2 ohms. You can verify. 2 ohms is the smallest resistance value here. If you calculate the combined resistance for this circuit, it will be less than 2. Remember, you can use the formula. This is more than 3 already, so you use the formula 1 over R equal to 1 over R1, which is 1 over 2, plus 1 over 5, plus 1 over 6. If you work out this, solve it, and verify that the total resistance will even be less than these two, to be less than the smallest resistance in this circuit. So, which means that the total resistance is going to decrease if you add resistors in parallel to a particular circuit. All right, so like I said, the correct option to that question 19 is B. Option B, decreases. Total resistance will decrease. Total resistance decreases. All right. So the last question we have here, I'm wiping this side of the board. Sorry that I am moving, the network interruption. Just attempted to destabilize this class, but thank God we didn't give up. Question number 20 is calculation based. 3 5 ohms resistor. 3 5 ohms resistors connected in parallel have a potential difference of 60 volts. Have a potential difference of 60 volts and applied across the combination. Applied across the combination. The current in each resistor is, so here in the question we have 3 resistors. Each of them is 5 ohms. Now one thing you should know is that, now the question says that the current, as the resistors are connected in parallel. Since the resistors are connected in parallel, remember that parallel arrangement will share the total current that will enter them. But there's something significant about this question. Each of the resistors is 5 ohms, so they have the same value. Which means if the current shares, it's still the same value of current that will flow through each of them, right? Like in this case, now if the current shares here, the highest current will enter these 2 ohms. Because these 2 ohms is small. Is the smallest of the 3. You know that current is inversely proportional to resistance. So the smaller the resistance, the greater the current flow. So more current will flow through these 2 ohms. Then the next greater current will flow through 5. The smallest current will pass through this 6 because this 6 has more resistance. But if it happens that these, they are of the same value, let's say 2, 5, 5, 5, I1 will be equal to I2, it will also be equal to what? I3. So this is something you should know about this question. Is that okay? I read the question again and then I will solve. 3 5 ohm resistors connected in parallel have a potential difference of 60 volts applied across the combination. The current in each resistor is, so this is what we're going to do, very simple. We'll calculate the total current. And then once we calculate the total current, we'll now divide it by 5, I guess, something like that, and see what we're going to get. So let's see. So we have R1 to be 5 ohms. Let me write R1, R2, 5 ohms. Then R3, 5 ohms. And then the voltage is 60 volts. The voltage is 60 volts. So from here, since these guys are connected in parallel, according to the question, they are connected in what? In parallel. Let me show you about something related to this parallel connection. Since we have 3 resistors here, yeah, I can use 1 over R1, sorry, 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3 to solve. But could we find LCM of this guy and see something? If I work out the LCM of this, I think I'm going to get 1 over R equal to R1, R2 plus R1, R3 plus R2, R3. Then divided by their product, R1, R2, R3. So from here, if you inverse, take R up, bring 1 down. R divided by 1 will give you R. Do the same thing here, inverse. This will go up, this will come down. What I'm trying to tell you is that for 3 resistors, just like that thing I showed you for 2 resistors, R1 times R2 all over R1 plus R2, you can do the same here. But this is how the formula will be like. However, I think once it is up to 3 resistors and above, please don't do something that will get you into trouble in exam. Like in this case, this will be R1, R2 times R3, then divided by R1 times R2 plus R1 times R3 plus R1 times R2 times R3. All of this is just based on LCM of these guys, then solving and making R subject of the formula. Sorry that I had to show you this. But I wouldn't do it because of all these R1, R2, R this, R that. Or maybe I'll leave this formula, we'll solve with this, and then I'll use this to still verify. Or should we just use this straight on? You know, this is going to be 125, 5 times 5 times 5. Okay, 125 all over. You've seen the formula, you can memorize it. But don't do this if they are up to 4 resistors. Please. In fact, I advise you, just use only that one of 2 resistors. If you come for 3 resistors, use this formula you know. R1 times R2 will give you 25 because it's 555. So 5 times 5, 25, 25, 25, which will be 75 if you add them up. Your R, total resistance, will now give you 125 divided by 75. What will you get? Permit me, I'm going to use, should I use calculator? Let me use calculator, work that out. 125 divided by 75 should be there about 1 point something. So let's see, 1.666. So that is equivalent to 1.67 ohms. Can also calculate using this to confirm. Let's solve and see. From here, it implies that 1 over R is equal to 1 over 5 plus 1 over 5 plus 1 over 5. Right? Let me see how it goes. So 1 over this will now be equal to LCM of this is 5. If LCM of that is 5, that is going to give us 5 then all over. 5 divided by 5 is 1 times this is 1. In fact, this is common denominator, so simply add the numerator. No time to waste. This is basic maths. Then to get your resistance, turn upside down, inverse. R will go up, 5 will go up, 3 will come down. So this implies that total resistance is 5 over 3. If you divide 5 over 3, what are you going to get? 1 point something. You can find out. 5 divided by 3 still gave 1.6666. You know, approximately 1.67 as this one. 1.67 ohms. But remember what I said in the exam, please. If you have up to 3 resistances in parallel and you want to, 3 resistors in parallel and want to find the overall, the total, I wouldn't really want you to do this, at least for this stage, except if you have good knowledge of mathematics. I'd rather prefer you go through this method which you already know very well. If it were to be me, I would use this. So let me wipe this one, please, and leave you with what you had already known. So that is it, but I've proven that both will give you the same result. Now that you have gotten the total resistance, we can now calculate the total current. Current is equal to 60 divided by the total resistance, 1.67. And that 1.67, 60 divided by 1.67. 35.92. So let's make it 35.9 ampere. This is the total current that will be delivered to that circuit where each of the resistance is 555. So if that current, now let's assume that this is the circuit per se, 555 ohms, the current enters, that current will be shared by these 5 guys. Sorry, by this, 55 ohms resistance. And to do that is just simple, you've just got to divide this thing by 5. Do you understand that, right? They are of the same resistance value. So you don't need to use that current divider rule or something, the one that we go through this and that is not necessary. They are equal. Therefore, divide the current that flows through each of them. Current through maybe I1 will be equal to I2, it will be equal to I3, since they have the same value. I've explained that to you before I started solving. And that, of course, will be 35.9 divided by the 3 guys. Divided by what? The 3 guys. And if you divide this, what are you going to get? 35 divided, that's 35.9 divided by 3. That's 11.9. So this is equal to 11.9 ampere. You are dividing by 3. That 3 means 3 resistors. You don't need to use that 5 for, say, you're using current divider. It's not necessary for this question. It's not necessary. Now, based on the options given to us, all of them are in whole numbers. So this is approximately equal to 12 ampere. And so the options, option A, 4 ampere, no. Option B, 36 ampere, no. Option C, 12 ampere, correct. So the correct option there is C. And that is that for this question number 20. This is Q20, I didn't indicate. And of course, all the questions that have been provided by group 1. And I hope you've learned something from this class. I hope you've learned something. At least within what we tried to do, I was able to solve questions on resistor connection, when they are connected in series and in parallel. So at least we've been able to touch all those things. I would like us to solve this last question. I didn't see any such question there. So I'd like us to solve it on I'd like us to solve this question. The question reads, a cell of EMF. I wonder why, in looking for questions, why group 1 did not even see any question of this type. Well, you guys tried, but your best was not enough. Group 1, take note, your best was not enough. There are other key questions in electricity I was actually expecting also added to the ones you provided. A cell of EMF 12 volts and internal resistance 4 ohms is connected to an external resistor of resistance 2 ohms. Is connected to an external resistor of resistance 2 ohms. Find the current flow. I hope the network is still intact. Okay, so let's deal with this. A cell of EMF 12 volts and internal resistance 4 ohms is connected to an external resistor of resistance 2 ohms. Find the current flow. So from the question we are given the EMF, let's take this as question number 21, is miscellaneous. We are given the EMF of the cell and we use capital E to represent it, 12 volts. We are given the internal resistance of the cell, small r, and we use small r to represent it, that's 4 ohms. We're also given the external resistor, That external resistor value has a resistance of 2 ohms. The examiner now asks us to find the current. So whenever you meet something like this, you want to recall that current is equal to the electromotive force EMF divided by the sum of the internal resistance and the external resistance. So this will now give us 12 divided by 4 plus 2. Then the current will now give us 2 ampere, because 12 divided by 4 plus 2 is 6. 12 divided by 6 will give you 2. Option A, 3 ampere. Option B, 2 ampere, which of course is the correct answer. Option C is 5 ampere. Option D is 4 ampere. So here the correct option is option B. Option B, 2 ampere. All right, so I hope you've learned something good about this. So if you have any question, remember what you can do. You can send your question across, right? Become a member of this channel. To become a member of this channel, you support GMAETS 41 either on platinum level or on diamond level. Platinum level is 2,000 naira monthly. Diamond level is 4,000 naira monthly, whichever that is convenient for you. GMAETS 41 will appreciate that. Then send your name, right? Your full name, where you are contacting GMAETS 41 from. Send it to this contact on WhatsApp. Then you will be added to our WhatsApp group so that you follow up with our regular updates. I'll be seeing you in the next class, right? God willing, tomorrow. To have a wonderful night rest.